Genre: Expository Text. Earthquakes by Sneed B. Collard III. Essential question: how do people respond to natural disasters? Read how science can help people prepare for earthquakes. A shifting planet. We like to believe that the ground under our feet is solid and secure. People who have felt the ground shake know differently. They have lived through an earthquake. Earth's crust resembles a jigsaw puzzle more than a solid sphere. Like a puzzle, the crust is divided into different pieces that fit together. These pieces are called plates. Earth's plates float on top of a layer just below the crust called the upper mantle. The upper mantle is solid rock, but it behaves like a thick gel. Heat from deep inside the earth moves through the rock and causes it to slowly swirl and flow. Myanmar residents inspect large cracks on a road after an earthquake struck the area. Dr. Inés Cifuentes is a seismologist, someone who studies earthquakes. She likes to compare the movement of Earth's plates to boiling milk. When you boil milk, she says, you get that little surface layer of cream on top that moves and dances around. That's what's going on in the Earth. Except that Earth's crust is much harder than the layer of cream. As the mantle boils, it pushes and pulls the plates above it. It's at the edges of these plates, Dr. Cifuentes explains, where we have most earthquakes. The white lines on the map above show plates on Earth's surface. The red dots show where earthquakes have occurred. Earth's largest quake, a first-hand account. Dr. Inés Cifuentes became a seismologist for a very good reason. She and her family lived through the largest recorded earthquake in history. This was the 1960 earthquake that struck Chile. As Dr. Cifuentes explains, in April 1960, my family moved to Santiago, Chile. Just a few weeks later, on May 21st, we were woken up by strong shaking. Then, 33 hours later, a gigantic earthquake hit the southern part of Chile, and with it, an enormous tsunami. About a year later, we took a trip to the northern end of the earthquake zone, and that's where I saw that the land had actually been raised up a meter or so. I saw these huge changes, and that impressed me, that the Earth could actually do that. Later, as a graduate student, I wanted to know how big that earthquake was, how long it lasted, and whether it was preceded by a slow earthquake. I worked on this problem for 4 years. I was able to calculate that Earth's largest recorded earthquake had a magnitude of 9.5. I also confirmed that a slow precursor, forerunner, had occurred 15 minutes before the main earthquake. I am very proud of this work. People stare at a gigantic crack on a street in Valdivia caused by the 1960 Chilean earthquake. Whose fault is it? Earth's plates crash together, spread apart, and slide against each other. Wherever they do this, they cause breaks in Earth's crust. Seismologists call these breaks faults. Usually the blocks of rock on each side of a fault just sit there stuck together. But when enough pressure builds, the two sides of the fault can suddenly shift or slip. This sudden movement releases waves of energy. These waves travel through the earth. We feel them as earthquakes. Most faults do not slip and cause earthquakes. Around the globe, however, active faults cause hundreds of earthquakes every day. Most are too small for us to notice. Once in a while, Earth unleashes a whopper. The diagram below shows a normal fault, which is a crack or fracture in the Earth's surface. Movement along the fault can sometimes cause earthquakes. Tsunami terror. When an earthquake occurs under the ocean, it often moves a substantial amount of water above it. This creates a fast-moving wave called a tsunami. Tsunami. Out at sea, the wave may be only a few feet high. As it reaches shore, however, the wave can tower into a monster. It can hurl water for miles inland. Tsunamis can travel thousands of miles. In 1960, Earth's largest recorded earthquake struck the country of Chile. It produced tsunami waves up to 82 feet, 25 meters high along the coast. The tsunami also raced across the Pacific Ocean at a speed of more than 150 miles per hour. It struck the shorelines of Hawaii, Japan, Alaska, and other places. Hundreds of people drowned. The disaster zone in Kesennuma, Japan, 2011, 100 days after the massive earthquake and tsunami. The 2011 Japan earthquake produced tsunami waves more than 30 feet, 10 meters high. The 2004 Indian Ocean earthquake in southern Asia produced 50 feet, 15-meter tsunamis. These tsunamis engulfed entire cities and shorelines. The waves swept away buildings, cars, and people. Japan, southern Asia, and Chile had experienced many powerful earthquakes and tsunamis before. Why were so many people unprepared? Predicting earthquakes. Seismologists are very good at measuring earthquakes. However, they still can't predict when earthquakes will happen. There was a time, Dr. Cifuentes explains, when I think scientists felt that predicting earthquakes was just around the corner, that we were going to be able to predict earthquakes very soon. But it's clear now that it's not around the corner. In fact, some have given up entirely on predicting earthquakes. One reason that earthquakes are unpredictable is that scientists cannot collect enough information to understand where and when an earthquake might happen next. Although scientists have placed special instruments in many earthquake zones, earthquakes still surprise us. Scientists, for example, had believed the next big earthquake in Japan would happen farther to the south, closer to Tokyo. Instead, it struck farther north. A powerful tsunami forced people to flee to the roof of a control tower in a flooded airport. Planning for earthquakes. Even though we can't predict earthquakes, we can prepare for them. Many seismologists help make information available to people so they can plan for and respond to earthquakes. This is especially important near coastal areas. Once the shaking goes on for more than 30 seconds, Dr. Cifuentes says, it's pretty simple. You have to run away from the ocean and run uphill. You have maybe 15 or 20 minutes to reach higher ground. How cities are built also affects how many people survive an earthquake. Cities in many countries have special building laws. Buildings must be strong and flexible. That way they won't collapse during an earthquake. In some countries, however, buildings are often poorly built. The 2010 Haiti earthquake, for example, killed between 46,000 and 316,000 people. Unlike the earthquake in Japan, many of these people were killed by collapsing buildings and falling debris. However, earthquakes don't just destroy. They also create. They help make the mountains, coasts, and other landscapes we see around us, Dr. Cifuentes explains. This is worth remembering as we learn how to predict and survive earthquakes in the future. Utility ducts like this one are being constructed to protect underground wires, cables, and pipes in the event of an earthquake. What to do during an earthquake. If you are indoors, drop to the ground and crawl under a sturdy piece of furniture until the shaking stops. Stay away from glass, windows, outside doors and walls, and anything that could fall, such as a hanging light or fan. Stay in bed if you are there when the earthquake strikes. Protect your head with a pillow. Only move from the bed if there is a heavy light or fan above you. Use a doorway for shelter only if you know it is strongly supported. Stay inside until the shaking stops and it is safe to go outside. Do not use elevators. If you are outdoors, move away from buildings, streetlights, and utility wires. Avoid any space where there is falling debris, such as glass. Once in the open, stay there until the shaking stops. Stop and check. Reread. How can you protect yourself if you are indoors during an earthquake? Reread to check your understanding. About the author. Sneed B. Collard III believes that people can find science anywhere they look. His mother and father were both biologists, so Sneed grew up with exposure to science every day. He has written more than 40 science books for kids, many of them inspired by his own life and interests, including his frisbee-catching dog. Today he lives in Montana and enjoys writing about the American West and its natural beauty. Author's purpose. Sneed B. Collard III uses interviews with scientists to inform readers. How did reading about Dr. Inez Cifuentes' work help you to better understand earthquakes?
Respond to the text. Summarize. Summarize what you learned about earthquakes. Information from your Venn diagram may help you. Write. How does the author use text features to help you understand how earthquakes affect people? Use these sentence frames to organize your text evidence. The photographs show. The author also helps me understand earthquakes better by. I can see that earthquakes.
Make connections. How can science help people prepare for earthquakes? Why should people take warnings about tsunamis seriously?